In this video, I'll solve some questions from CBSE 2024 board exam question paper of set 1. These questions are from chapter 1 and 2. I'll discuss one 1-mark question, one 3-mark question, and two 5-mark questions. This is a 1-mark question. A thin plastic rod is bent into a circular ring of radius r. It is uniformly charged with charge density lambda. The magnitude of electric field at its center is. Five options are given. You can pause and type this question. Here is the solution. So this is a plastic ring which has got uniform charge density lambda. So to find the electric field at the center. So one way to do is take pair of elements and find the electric field due to the pair, and then take the second pair. So if we sum the electric field due to all the pairs, that will be the electric field due to this ring. So electric field due to a pair at the center will be 0. Electric field is defined as a force on 1 coulomb charge. So we place 1 coulomb here and assume lambda is positive. So because of this element, there will be a repulsive force in this direction. And because of this element, there will be a repulsive force in this direction. And both these forces will be of equal magnitude but opposite direction. So they will cancel. So the net force due to the pair will be 0. So if we take the second pair, again the force will be 0. So the net electric field, which is summation of the electric field of all the pairs, will be 0. Another way to get the answer is, place 1 coulomb here, by symmetry, the force on that will be 0 because it will get equally repelled in all directions. 1 coulomb placed in the center. Because of the element here, will get repelled in this, because the element here will get repelled in this direction. The element here will create a force in this direction. Similarly, there will be a force in this direction, and the diameter of opposite elements will create a force in this direction. So all the forces will look like this. So they will cancel. The net force acting on 1 coulomb will be 0. If you place 1 coulomb here, it will not move in particular direction because all directions are same. So it will not move. So the force is 0. So correct option is option B. Basics that are required to solve this question. First, you should know the definition of electric field. Electric field, by definition, is force on 1 coulomb. So by using Coulomb's law, it is 1 by 4 pi epsilon naught, product of the charges Q and 1. Q is the source charge, divided by the distance square, distance between Q and 1. This is for a point charge. But in general, if the charge is distributed like this, then we can divide this charge into small elements. And since the element is very small, each element will act as a point charge. So I can find electric field at this point due to one element using this formula, and the second element, and to add all these electric fields to get the net electric field at this point. So the electric field at point P due to the distributed charge like this is summation of electric field to the individual elements. And when the element size become very, very small, delta will become dE, and the summation will become infinite summation, which is integration. When the element size is becoming small, the number of elements will become large. So the summation will become infinite, and integration nothing but infinite summation. So for a distributed charge, this is how you find the electric field. This is the next question. It's a 3-mark question. A cube of side 0.1 meter is placed as shown in the figure in a region where the electric field E is 500x I cap exists. Here exists in meters, SI unit, and electric field is in Newton per coulomb. This is also SI unit. Calculate the flux passing through the cube, and B, charge inside the cube, within the cube. This is a straightforward question. A similar question is there in the NCERT example, solved example. Important on this question. A part is you have to find the flux through the cube. So the flux through the cube is sum of flux through the left face, this one, plus the flux to the right face, and the top face, and the bottom face, and the front face, and the back face. So there are 6 faces of the cube. So the flux coming out of the cube is sum of the flux coming out of the individual surfaces. And the flux through top face, bottom face, front face, and back face is 0 because the electric field is in the x direction. Electric field is in the x direction. Electric field is in the x direction. And this top face, the area vector is upwards. So the angle between the area vector and the electric field is 90. So flux is E dot ds. So E dot B is 0 if the angle between A and B is 90 degrees. Similarly, the bottom face, the electric field is towards right, but the area vector is downwards. Again, the angle between E and area vector is 90. The front face, the area vector is outwards like this, and the electric field is in the x direction. Again, the angle is 90 degrees. Similarly, the back face, the area vector is outward, and the electric field is towards right, and the angle between the E and ds is again 90. Another way to understand is the electric field, which is towards the x-axis, will cut only the left face and the right face. As for the other 4 faces, it will just graze that surface, it will not cut that surface. So flux is measure of how many field lines are cutting the surface. So the field lines or the flux through these 4 faces is 0 because the electric field is not cutting the surfaces, just touching them or grazing them. So the flux will come only from the left face and the right face. So the flux of the left face is E dot ds. The electric field the left face dot ds, and angle between the left face and the area vector is 180 degrees. On the left face, the area vector is outward vector, so this is the area vector, and the electric field is towards right, so the angle between them is 180 degrees. So cos 180, which is -1. So and electric field on the left face is uniform because electric field depends only on the x value. So for the left face, the value of the x value is same for all the points on the left face, which is 0.1. So electric field is uniform on the left face, so it will come out, and integral is in the total area of the left face. Similarly, on the right face, the electric field is ER, which is towards right, and the area vector is also outward. So the angle between the electric field vector and the area vector is 0 degrees for the right face, cos 0, and ER, which is the electric field on the right face. For all the points on the right face, the x value is same, which is 0.2 because the size of the cube is 0.1. So this is 0.1, this is also 0.1. So the value of x for all the points on this right face is 0.2. So that is uniform. So ER will come out of the integral sign. Integral is so ER into E. So this is used here. So electric field on the left face is 500 into x value for the left face, which is 0.1. So 500 into 0.1 is the electric field. And this minus sign comes because of this minus sign here, because area vector and electric field vector are anti-parallel. The angle between them is 180 degrees. On the right face, the electric field is 500 into x, which is 0.2, and it is plus. And E is the area of the face. Area of the face is cube side is 0.1. So area of the face is 0.1 into 0.1, which is 0.01. So area E is 0.01. So simply we get flux as 0.5 volt-meter. Flux, the units of flux is E to ds. So electric field unit is volt per meter. and ds is area meter square. So volt per meter and meter square is voltmeter. Now that means the electric field is force on unit charge. So its unit of electric field is meter per coulomb, and ds is meter square. Both are same. Voltmeter is same as Newton per coulomb into meter square. So the answer is 0.5 in SI units. B part of the question, charge within the cube. There could be charge present inside the cube. If it is there, we have to find that value. So Gauss law is applicable for any closed surface. This cube is a closed surface. So applying Gauss law to the closed surface, we get flux coming out of the cube is charge present inside divided by epsilon naught. Flux coming out of the cube is same as the flux we actually calculate the A part, which is 0.5 in SI units. So 0.5 into epsilon naught equal to Q1. Epsilon naught value is given in the question paper in the beginning. So we can use that value. This again in SI units. So using that we get the charge inside as 4.427 into 10 to the minus 12 coulombs. Let's go to the next question. This is a 5-mark question. 31A, the first part, derive an expression for potential energy of an electric dipole P in an external uniform electric field E. When is the potential energy of the dipole? 1 maximum and 2 minimum. This is the first part of the question. It's on electric dipole based on external electric field. Second part, again electric dipole, concept point charges -1 picocoulomb, pico is 10 to the minus 12, and plus 1 picocoulomb located at 0,0 and 3 mm, 4 mm, respectively in XY plane. An electric field E of 1000 volt per meter I cap direction is switched on in the region. Find the torque acting on the dipole. First part of the question, you have to derive the expression for potential energy of a dipole. So this is a basic concept of physics. Potential energy stored in the system is work done to build it. And we can choose a convenient reference point for zero potential energy. Another basic thing is work done is by a force is F of ds for a translation motion. If it's getting rotational motion means F will become torque and ds will become angular displacement torque theta. The units of this and this are same. Force is Newton and ds is displacement. So Newton meter. Torque is R cross F. So Newton into meter and theta is radians. So again, this is Newton meter. Radian is considered as dimensionless. So unit of this and this are same. So this is a dipole, -1 plus q separated by distance from A or D. And the electric field is vertically upwards. So the work done to rotate this dipole by a small angle d theta is torque into d theta. So the work done from a reference position to a particular angle theta is, you have to integrate this dw from within this limits, theta reference to theta. And torque of a dipole in external uniform electric field is given as P cross E. This is also a formula which we can remember. And P cross E is nothing but P into sine theta, where theta is the angle between the two vectors P and E. And so integral of cos theta is, integral of sine theta is cos theta or minus cos theta. Okay, and then P is constant, or it will not change in theta because Q is fixed, separation is fixed. So when theta is changing, P will not change. So P is not a variable. So when the external electric field E is also uniform, it will not change in theta. So P and E will come out of the integral sign. So this integral sine theta, which is minus cos theta or plus cos theta. Derivative of cos theta is minus sine theta. It's minus cos theta. And you have to put the limits and take the reference for theta as 90 degrees. We did cos 90 minus cos theta, so it will become minus P cos theta. And this can be written in vector form as minus P dot E, where theta is angle between the two vectors P and E. So this is the work done to rotate from theta to theta. So this is This will get stored as potential energy of this dipole. So expression of potential energy is minus P dot E. And the first part of the question, after deriving this expression for potential energy, we have to find when the potential is maximum and when it is minimum. The potential is derived as minus P dot E, which is P into cos theta. So as the dipole rotates, the only variable is theta. P and E are fixed. So this cos theta will vary from -1 to +1. So when cos theta is -1, because of minus sign here, this will become maximum. And when cos theta is +1, this will be the maximum negative value, so it will become minimum value of the potential energy. So when theta is 0, potential is minimum and its value is minus P. And when theta is like 180 degrees, cos theta is -1, so potential energy will be maximum. And when theta is 0 degrees, P, which is from -2 to +2, will be in the same direction as E. P vector and E vector are parallel, so this is minimum potential energy position. And when P is when -q is and +q is here, this is the maximum potential energy position because P and E, P dot E will become negative, and one more negative sign is the formula. So this is the position for the maximum potential energy. And this is the stable equilibrium position. Another basic concept of physics is minimum energy position is a stable position. So this position is stable equilibrium, and this position is unstable equilibrium because the energy is maximum. Second part of the question, you have to find the torque on a dipole kept in external electric field, and the formula is P cross E. So it is P into E into sine theta. Theta is angle between P and E. P is Q into the separation between the charges to A or B. And sine theta here, the two charges are kept at one charge is placed at the origin, minus Q at the origin, and the second charge plus Q is kept at 3, 4. So minus Q is at the origin 0, 0, and plus Q is here somewhere. It's at 3, 4 in mm. Okay, so the distance between the two minus and plus. The distance between the two, it's 5 mm. Because 3, 4, 5 form a right angle triangle. This distance is 3. That is the meaning of 3, 4. And this distance is 4. And this is 90 degrees. So by Pythagoras theorem, this is 5 mm. So D is 5 mm. And electric field is given as 1000 in the question. And sine theta, this is the angle between this direction of P. P is from -2 to +2. And electric field is I cap. So the angle between P and E is this angle theta. And sine theta is 4/5. Opposite side by hypotenuse. And electric field value is given in the question as 1000. So using this, get this value as 4 into 10⁻12 Newton meter. So in this question, this is the only tricky part where you have to find the separation between the two charges. One charge is at 0, 0, other charge is at 3, 4 in mm. So that means the separation between the two charges is 5 mm. After that, it's a straightforward formula. This is the next question. This is also a 5-mark question. Again on dipole. An electric dipole of moment P equal to Pi cap, consisting of charges -1 and +2 separated by a distance 2a, is placed along x-axis with its center at the origin. Show that the potential B produces dipole at a point x, where x is much larger than a, is equal to Okay, this is a theoretical question. You have to derive this formula. Second part of the question is two isolated metal space S1 and S2 of AD 1 centimeter and 3 centimeter respectively are charged so that both of them have the same charge density 2 by pi 10 to the minus 9 coulomb per meter square. They are placed far away from each other and connected by a thin wire. Calculate the new charge on sphere S1. So the first part of the question, you should know what how the potential is defined or derived, the formula for the potential for your point charge is K Q by R square, where K is 1 by 4 pi epsilon naught. This is for a point charge. Suppose there are two charges Q1 and Q2. Potential at point P, which is the distance R1 from Q and R2 from Q2, is given by superposition principle. So the potential will be K Q1 by R1 square to the first charge plus K Q2 by R2 square to the second charge. And dipole has got two charges. One is plus Q and minus Q. So you can put Q as plus and Q2 as minus Q. So this derivation is there in the inside text. So this is a dipole minus Q plus Q separated by distance 2a, and you have to find the potential at this point P. Let the distance of the point P from the center of the dipole be R, and the distance of P from Q will be R1, different from R, and P from the minus charge minus Q will be R2. Where R1 is more, R2 is R1 is less, R2 is more, and R is between R1 and R2. So potential at this point P by superposition principle will be 1 by 4 pi epsilon naught, the charge Q by this distance R1. The second charge is minus Q by the distance is R2. And this R1 I can write in terms of this distance R and this distance A using the cosine rule. So R1 square equal to R square plus A square minus 2AR, theta the angle between A and R. Similarly, in this triangle, second triangle, I can write R2 square as, in terms of these two, R square plus A square minus 2AR. The angle between these two is pi minus theta. This angle is theta, so this is pi minus theta. And cos pi minus theta is minus cos theta because cos in the second quadrant is negative. So that minus will make this minus as plus. Another way to remember is R2 is more compared to R1. So R2 will have a positive sign and R1 will have a negative sign. And we have to use the dipole approximation, which is R is, or the size of the dipole is much smaller compared to the distance where you're finding the potential. So that means R is much greater compared to E. So that means A by R is delta, very small quantity. So this one, I can take R square outside. So it will become R square into 1 minus E cos theta by R, and this will become E square by R square. So E by R is delta. So this is delta square. This is delta. So when delta is small or very small, because this is much greater, so delta square can be neglected. So neglecting this term, I'll get this one. Similarly, R2 square, I have to take R square outside. Exactly the same thing. Instead of placing, we'll have minus A. So we'll get this as R2 square as R square into 1 plus V cos theta by R. In the formula, what it means 1 by R1. So first I'll get 1 by R1 square, or I can get 1 by R1 as square root of 1 by R1 square. Take the reciprocal of this one, it will become 1 by R, and 1 by R square. Take the square, it will become 1 by R, and this one, reciprocal means it will become minus 1, and then take the square root, it will become minus half. So this one raised to the power minus half. Similarly, 1 by R2 is, take the reciprocal of this one and the square root. So this will become 1 by R, this will become minus 1, and then root will become minus half. Another binomial approximation is 1 plus a small quantity delta raised to power n is approximately 1 plus n delta. This is a standard result. Okay, so this A by R is less than 1, much less than 1. So this into cos is this also much less than 1. So this whole thing is small quantity. We can call it delta. This is n. So this will become 1 plus n delta. So 1 plus this minus half will cancel, this minus will become A by R cos theta. Similarly, this also a small quantity. So n is minus half. So it will become minus A by R cos. Here this will be plus because this minus will cancel, this minus become plus. Here is just minus and will come here. So once I got 1 by R1, 1 by R2, I can use in this one. I will take Q outside. So become Q by 4 by epsilon naught into 1 by R1 minus 1 by R2. So Q by 4 by epsilon naught and 1 by R1 minus 1 by R2. So I have to subtract these two. When I subtract these two, this will get cancelled and this will get added up. So it become 2A cos theta by R square. And Q and 2A can be combined as P because Q is the charge into the separation which is 2A. Become P cos theta by 4 by R square, 4 by epsilon naught R square. And P cos theta can be written as P dot R cap because P dot R cap is P into A dot B is AB cos theta. So it become P into 1 because R cap angle is 1 and the angle between the two which is cos theta. So P cos theta can be written as P dot R cap. So this is the first part of the question. Okay, so R we are having X here. Because of the point X, R will become X. This is for a general point at a distance R, but suppose the point is on the x-axis. This is the x-axis. So if we take the point P here, this distance is R, which is same as X, because the point is on the x-axis. So in this form, if we put R as X, we will get this result. Second part of the question, two metallic spheres S1 and S2 of AD 1 centimeter, 3 centimeter charge, so that they have the same charge density. They are placed, this is the initial condition. After that, they are connected by a thin wire. So once they are connected with thin wire, there will be some charge redistribution. So to find the final charge on the sphere S1, this was a standard question. So let the initial charge on the spheres be Q1 and Q2, capital Q1 and capital Q2. And once they are connected by a thin wire, the charge will get redistributed. And let the final charge on one be Q1, small q1, second sphere be Q2. But since the charge is conserved, the initial total charge and the final total charge will be same. So Q1 plus Q2 should be equal to small q1 plus small q2. And initial charge Q1 is the surface area of the charge sphere R1, that's 4 pi R square, R1 square, into the charge density sigma. And initial charge on the sphere 2 is 4 pi R2 square into sigma. Sigma is the surface charge density. And it is given in the question as 2 by pi into 10 to the minus 10 coulomb per meter square. It's surface charge, so charge divided by area. So the unit is coulomb per meter square. And once they are connected by a thin wire, both the spheres and the wire will be at the same potential because you have two conductors connected by a wire which is a conductor. They will all be at the same potential. And let that common potential be B. And for a spherical capacitor, V is Q1 by C1. And for the second capacitor, it's Q2 by C2. And C1 is 1 by 4 by epsilon naught R1 and C2 is 4 by epsilon naught R2. This capacitor is spherical conductor. So we have one equation here in variables Q1 and Q2. Second equation here in variables Q1 and Q2. Capital Q1 and Q2 are known because sigma is known, R1 is known. Similarly, R2 is known. So the only unknowns are small q1 and q2. And we have two equations, two unknowns, which can be solved. So first equation capital Q1 I can put as 4 pi R1 square into sigma, and Q2 as 4 pi R2 square into sigma. Go to Q1 plus Q2. And in the second equation, Q1 by C1. So 4 pi epsilon naught is common, so it will become Q1 by R1 equal to Q2 by R2. 4 pi epsilon naught will cancel here and here. So only 1 by R will remain. So Q1 by R1, Q2 by R2, and Q1 equal to Q2 into R1 by R2. R1 is small sphere. Radius is 1 centimeter. R1 is 1 centimeter. R2 is 3 centimeters. So R2 is the second sphere is biggest sphere. So R1 by R2. So it's Q2 by 3. R2 is 3. R1 is 1. So now combining these two, I can take 4 pi sigma outside common. And then R1 square plus R2 square equal to Q1 is Q2 by 3 and Q2. So this will become 4 by 3 Q2. 4 pi sigma is given in the question as 2 by pi, reduced minus 9. R1 square is 1 square, plus this is 3 square, so it will become 10, and be centimeter square. Converting centimeter square to meter square, I get this factor of 10 to minus 1. So from this Q2 values, this much, but question they are asking charge on the first sphere, final charge. So Q1 is Q2 by 3. So this divided by 3 is 2 into 10 to minus 12.